All right, so there's a lot going on in this question, okay? Find the domain, so your inputs, your range. Oh, good, that doesn't need the range. The points of discontinuity and the intercepts. And then determine if the discontinuities are removable or non-removable. Let me do it by hand first, and then we'll see what we could have found out by a calculator. The key here is to factor everything. So on the top, I'm going to write that as -5 times -6 plus x. Now, you'll understand why I did that here in just a second. On the bottom, I'm going to write that as x minus 6 times x minus 5. Now, what I'll do now is just flip around. Instead of writing it -6 plus x, I'll write it as x minus 6. All right, now look. What are two important rules in math? You're not allowed to divide by 0, and you're not allowed to take the square root of a negative number if we're dealing with reals. Okay, so this has nothing to do with square roots, but it has a lot to do with division. So where are our points of discontinuity? Wherever we would divide by 0. So x is going to be all reals except for 6 and 5. X is not allowed to be 6, not allowed to be 5. So that is your domain. This right here is your domain. That's all the values that we can have for x. So x is all of the reals except 6 and 5. Okay? The x and the y intercepts, I always think it's easiest to maybe use our graphing calculator to find that out. Now, the points of discontinuities. This graph is going to have discontinuities at 6 and 5. But the x equals 6, that is a removable discontinuity because we can cancel it out. What that's saying, check this out. Let's graph this. You're going to have to use parentheses to graph this stuff right. So we're going to graph -5 times, -5 times x minus 6, close them both, divide that whole thing by x minus 6 times x minus 5. Notice I have two sets of parentheses on the bottom and the top because I got to do the entire top divided by the entire bottom. Let's graph that thing. Uh-oh. What did I do wrong here? Oh, I got it in the wrong order. So this should be that, and that should be that. Let's try that now. All right. So it looks like our x-intercept, our y-intercept is 0, 1. Notice at 5 and 6, there is an error. That's the point of discontinuity, okay? And it looks like no matter how far we go, we're never going to hit 0. So there are no x-intercepts. It never hits the x-axis. Notice if I look at the graph, that means those are asymptotes, horizontal asymptotes. Okay? But here's what I want you to see. If I graph this as -5, so if I just cancel the x minus 6's, the graph will be the exact same. -5 divided by parentheses x minus 5. So notice that's a lot easier to put into your calculator. Watch. You're not going to be able to see the graph because it's going to turn off. Oh, there it is. Look, it drew over it. But when I look at this table, there is no longer going to be an error at x equals 6. And the reason why is we took it out. See that? So there is some removable discontinuity at x equals 6. But we're never going to be able to put in a 5 because we can't take it out. Okay? I feel good about that. I hope that helps. Boom!